because first
Yeah,
session is demo session, so you can see the link.
yeah, Gautam, you can continue with the second session. I will be
Okay.
contacted with the second session for you next time. Okay.
Okay, the first session is only regarding what is the current market, how are the job openings, who is eligible, so what are the methodologies we saw. So you can take, you can ask Satish, he'll be giving you the demo link to you. You can go through that.
Okay.
Okay.
Sure, sure, sure. Yeah.
Okay. Yeah. Yeah. So today's agenda is regarding cloud computing because everyone thinks that the cloud is really driving the DevOps, because in the DevOps scenario, because everyone is interested in getting the growth. So everyone wants least amount of money to be spent on their IT infrastructure. So if you want to spend least amount or negligible amount, you need to go with the cloud, because you don't need to buy a huge infrastructure, land, computing resources, new type of servers every 5 years, and huge amount of land, everything, because buying an infrastructure, buying a hard new data center is a cost you millions of dollars. So instead, if you go through the route of cloud computing, you'll be saving huge amount of money, and also you'll have a huge scale. Suddenly, your business got double. So you need around 500 new servers to be deployed in your production server. So you can't achieve that within mere days, because in an Amazon, if you want, you can ask Amazon has thousands more servers, and you can only use them only in your, what do you say, your peak time. Your peak time may be US hours, and your non-peak time may be Indian hours. So you can only add 100 servers during your peak time and release those servers back, so that you don't need to pay the other 12 hours of your peak time. So cloud computing will give you a lot of advantages, and when cloud computing is merged with the DevOps, right, it's a perfect combination for every startup and every major organization. So today around 80% of the major organizations are already using the public and private clouds. So we'll be seeing what are the different types of computing scenarios, what are the types of cloud solutions, all the ones which are currently being in the market. Okay. So today's agenda will be what is the history of cloud computing, what are the types of cloud computing, what are the cloud computing essentials and benefits, cloud computing service models, and cloud computing deployment models. So these things are required by you, because there are when you're going to a DevOps position, there will be a lot of scenarios, a lot of buzzwords you need to have in your mind, because someone will tell you, do you have shall we go with a SaaS solution, shall we go with a PaaS solution? Because in your, when you go into DevOps profile, someone will ask you like, okay, this is our requirement, how are we going to achieve this requirement? Okay. So everyone has their own solution, so you need to be positioned to provide a solution based on the requirement. Okay, so shall we go with this with a cloud solution, or can we go with the own data center solution? What is the cost? All these things you need to have a understanding, so that you can take a better decision and save money. Okay, guys.
Yes, Gautam.
Yeah, so we'll see so we'll see what is history of cloud computing. So whenever you see a new technology, right, that new technology will not be invented then and there. So all the small pieces related to that, right, they'll already be in place, and someone will come and attach all those things, so that it will become a new thing. So if you're inventing an iPhone, it's not a new iPhone, right? Already all the technologies were in place, so someone came and put a touch screen in that, suddenly it became a smartphone. The same way, all the building blocks, right, for cloud computing were already in place. So Amazon came and they have added all those what is a building blocks to the internet, and they made it as a cloud computing. So we'll see what are all the building blocks for the cloud computing, which became the history, right? So the first, right, the 1959, there was a scientist who started time sharing system. So time sharing was one of the most important concept, because in a traditional Windows system, right, if you log into a Windows system, you only have a, what do you say, you can only only one person can log in, right? But in a Linux system, more than one person can log into a SSH client, and he can start issuing commands. So there is no restriction, right? So that is called a time sharing. So a person, two persons can log into the same system and start using it, which is a time sharing, right? That was an earlier concept. This was some invented by a scientist called McCarthy in 1955. So in the 1969, what happened? So the Defense Research Institute, right? The U.S. government has a Defense Research Institute. It's called a ARPANET. So they have developed something called ARPANET. So they started communicating with the in the LAN. So they were able to send message who was in the own LAN system, right? They were able to start connecting. So this was the earliest first known network to the humans. So and after this, right, what they called American military has given it to the public, and the people called started internet. So but pri prior to this, right, it was only called internet. Only American military used to use the internet concept. So it was only legalized after some time. So internet, right, it is very important, right? So all the small building blocks, right, they were already in place. That's why. So in 1969, the LAN connectivity or internet was brought. So in 1970, the Unix system got invented. So the what you say, the fully time sharing solutions, all the platforms, like hardware agnostic. So prior to this, only operating system was only coming on one hardware. So 1970 came a platform, multi-platforms one. Okay, in the 1990s, what happened when the telecommunication companies, right? If you see the AT&T or Verizon, which are the heavy giants of US, or else if you have Airtel, everyone, right? They started requiring a type of network called virtual private network. So then the VPN services and what do you say, sharing across public environments with a secured environment got invented. So whenever you're joining your US organization network, right, you'll not be having a physical direct connection to the servers, right, or data center. What you do, you open a VPN service, or it's nothing but a tunnel. So you open a secure tunnel from your local internet to your data center. So this is called a virtual private network. You are recreating that network virtually in your local server. That is called a virtual private network. And virtual private network being is very important, because if you are buying a cloud computing, right, you will not be having that secure environment in your office, because normally if you are suppose you are working in Infosys. So what Infosys will do? Infosys will already open a connectivity, VPN connectivity from your office floor to the servers, so that once you are in your office network, you can start accessing the servers. But that is not the case. If you go to Amazon or AWS, right? Amazon, AWS, or Microsoft Azure, you should be able to connect to your servers from anywhere in the world, because they are in the internet. So that is why the virtual private network is a very important basic building block for a cloud computing. Okay, then in 1997, an Indian professor, right, he's called Ramnath Chapella. He has termed the coin cloud computing. So that person, right, he told, okay, if all of these things are happening in the cloud, through internet, then he told it is cloud computing. Okay, then in 2008, right, the NASA, NASA also builds a lot of software for its own purposes. So what they did, they have open sourced some tools through which it was easier to build the first hybrid cloud. So hybrid cloud or private cloud is nothing but you will have a cloud solution, but the cloud solution will only be restricted to your own organization or a certain types of organizations, not to the general public. So these type of clouds were possible with the what you say, with the type of softwares which are open source by the NASA. So NASA first built it, so they thought, okay, this can be useful for the public, so they open source the tool. Okay, so if you see these tools, right, the time sharing, the internet, the virtual private network, the multi-platform system, these are all the basic blending blocks. Today, when you need it, when you are going to sign up for an Amazon AWS or a Microsoft Azure service, what are you going to do? You sign up to their page, then you add your credit card to that, then you directly sign up. That's all. You're not going to buy 100 servers and put it in your own home or any office location, right? Amazon is going to take care of it. So Amazon didn't invent anything, right? All the building blocks were already in place. So what Amazon did, they brought everything into one place and they enabled it through the internet. Okay, guys, any doubt in this? So we'll see what are the types of computing. So what are the types of computing? So we'll see how the computing has evolved. So computing is evolved. So let me see what is computing. So whenever you're going to run an IT company or run any service, right, you need to have a computing in place. Computing is nothing but you need to have all the resources which are required for a network. So what are the basic resources, we'll see. So you need to have servers, you need to have a LAN connectivity, you need to have what do you say, routers, switches, you need to have load balancer, you need to have firewalls. All these things are computing resources through which you can achieve a complete computing solution. So we'll see what were the three types of what is the evolution of computing and how it has evolved. Okay, so the first one is the grid computing. So the grid computing was the earliest type of computing which was in place and which was used by the people. So these computing, right, the shared, how the resources were shared earlier. Okay, so the grid computing is nothing but it provides a platform in which computing resources are organized into one or more logical pools. Okay, these pools are collectively coordinated to provide a high performance distributed grid. So the grid computing, right, was the earliest type of a cloud computing example. So let me tell you an example. So earlier, right, in around 70s, right, people when they wanted to collaborate on a on a, what do you say, on a huge problem. So what do you say, trying to know the climate or trying to predict the weather or trying to predict something, right, requires a huge data center. That is called a that requires a huge computing resources, so that you use thousands of servers and you use that resources to try to know what is today's climate, what is tomorrow's climate, or all you'll give suggestions about when the cyclone is going to come, because these are all heavy compute based resources. So to do this, right, earlier scientists used to use the grid computing solution. So they were all the hardware resources were only utilized in one or two pools. So if I had a huge data center, I was not able to utilize different components. What was my solution is I was only able to use it in a one or two pools, and I was all using the resources to that pool itself. So so if the program runs or not doesn't run, all my computing resources were utilized into the grid computing. Okay. So these were all typically large products which were deployed across continents and countries, right? And and several other programs, right, which were idle also. Those computing resources were not being utilized by other programs. That is why it was called a grid computing. And other people, other than these own persons who have set up, right? Other people, it was very tough to connect to that systems, because people didn't have enough resources easily to utilize those resources as part of the grid computing. So from the grid computing, right, people have started evolving and the utility computing in place. Utility computing was the most standard before the cloud computing. So utility computing, right, in the 1990s, right, when there was a boom, you say the dot-com boom, right, during the 2000 or 1999, right, there was also startups. The startups are not only today, right? Startups were in the 1990s also, in 2000s also. Everything was startup. If you see Facebook, it was startup around what do you say, 16 years back, right? It was put in 2001, right? So Facebook was also a startup, right? So Facebook, when it started, it didn't have enough money to set up huge data centers. So at that time, right, in 1990s and 2000s, utility computing was a service. So utility computing was nothing but it was a predecessor to the cloud computing. So in the cloud computing, you'll have a lot of convenience, but in the utility computing, right, you didn't have any convenience. So you go to a data center provider, he will buy a data center, he'll buy all the servers, all the resources, right, the load balances switches, but he'll tell, you need to pay me for 1,000 servers, around 100 routers or 10 load balances for the year, no matter you use it or not. It is same like a water connection or a, what do you say, electricity connection. That is why it is called a utility. These are all utilities we use for a house, right? The electricity, water. The same way, it was utility computing. No matter you use it or don't use it, it's up to you. You need to pay him the cost for 100 servers or 1,000 servers for the year. So this was a utility computing. So people were not having enough softwares or services to easily create a server or destroy a server, and there was no enough mechanism to uh, capture all those services and create a billing service. That is why what they used to do, they used to give a physical connection to you for 1,000 servers, and they used to tell you use it or don't use, I don't care, you need to pay me. So these were the types of computing which were available for the common people, because this was better than the grid computing, right? So then comes the cloud computing. So what is cloud computing? So cloud computing is a model for enabling on-demand network access to a shared pool of configured computing resources. So here the computing resources are nothing but the networks, servers, storage, and applications and services. So prior to the cloud computing, there was no application as a service. So means the SaaS, right, software as a service, right, we know everything. The SaaS is a famous solution, right? So the SaaS got only possible through cloud computing. if you see the SaaS solution, right, it's possible. So if you see the most famous SaaS solution is Salesforce. Salesforce is the most perfect example for the SaaS solution, and it was only possible with the cloud computing. If you see Salesforce, it's only been around for 6 or 7 years, not more than that. Okay, so here, right, you can select mix and match whatever you want. If you want a server with 4 cores, it is possible. If you want a server with only 1 GB RAM, it is possible, and it can be used on a specific hours. You will tell, okay, I need 10 servers for 1 hour, then I'm going to destroy the servers. Then you will only pay for that 1 hour for the 10 servers. So it's so configurable. So these were the evolution of computing resources. Earlier it was a grid computing, people didn't have enough knowledge to use it, and there was huge amount of resources being wasted. Then it came the utility computing. The utility computing it was a better than grid computing. People were able to access the servers. Then uh, they had services to the resources, and they used to have a strict base of resources. They didn't have any what do you say time sharing or any on-demand network access. If they had access 100, they need to have 100. They can't, if they have a peak resource, they can't increase those servers. But in the cloud computing, you'll have enough benefits. So we'll see what are those benefits. So we'll see first what are the building blocks of cloud computing, then we'll see the benefits. So every cloud computing, right, if you take Amazon AWS or Azure, right, there will be 3 important aspects to it for every cloud computing solution. What is it? The first is the characteristics of it. What are the characteristics? So the characteristics are nothing but the same thing. What are the features of the cloud? Whether it has a good network access, whether it has a rapid elasticity, whether it can measure the services. Measuring the service is nothing but suppose I have used a service for 1.5 hours. Whether is it capable enough to capture that, okay, I'm using it for 1.5 hours or not. Whether it is capturing that, measuring the services effectively or not. And the next thing is on-demand self-services. So if I ask it, okay, suppose I need 100 servers, whether is it readily two customers with 100 servers. So it should be in a position to do that pooling correctly. Okay. Then the next thing is a service model. So the cloud can be introduced to user in 3 ways: the software as a service, platform as a service, and infrastructure as a service. Okay, these 3 ways are the service models. Okay, so we know SaaS is already famous. In the recent times, that platform as a service and infrastructure as a service are also hugely famous. So whenever you go with a public cloud, we'll see what are the characteristics and which name will be considered whenever which type of service you want. Then the fourth one is deployment. How are you going to deploy that service model? Okay, based on the deployment, the cloud will get a name called a public cloud, a private cloud, or a hybrid, or a community cloud. Okay, these are the 3 characteristics. So these 3, based on these 3 things, right, each cloud will get a specific name. Okay, guys, you have any doubts in this session, in this slide? Are we clear?
Yes, Gautam.
Okay, so we'll see why cloud computing, because everyone will need a certain aspect, because no one will upgrade anything, their own TV, their own mobile, or anything, because until unless someone sees a benefit something, they are not going to upgrade, or they're not going to uh, sure. Yes, Ishwar, in the later sessions, in the later slides, right, I'll tell you what is the infrastructure, how we'll be using it when we go through the cloud service models. Okay, so we'll see what are the benefits. Most of the people will know. We'll still run through it soon. So everything is the fresh software. So what is fresh software? Because when with a SaaS solution, right, when the latest versions of the application will be available. Because if you take a SaaS solution, right, SaaS solution is nothing but you're providing software as a solution, right? So using that, you'll have a fresh software always, because you don't need to wait for the upgrade everything, because that thing will be being taken care by other third-party provider, everything. Because if you take a Gmail, right, if Gmail will be updated in the backend, you're not concerned about Gmail. Whenever you access Gmail, you'll have the latest version of Gmail, right? It's not like, okay, you are an old customer, you'll get the old version. No, Google will make sure that each and every customer will get the latest version, because we are not handling that. We are using the Gmail as a software, as a service. That is called a software service. You'll get the latest software always. That is the first thing. And the second thing is you'll do more for less. So lower total cost of ownership. See, whenever you define any new project in your, whenever you create a new project, right, in your infrastructure, the first thing they'll see is what is the total cost of ownership. So the TCO is the most important aspect when a new, whether a new project in the IT, right, whether it should be taken up or not. Because whenever you start a new project, right, they'll tell what is the total cost of ownership. They'll see what products we are buying, what is the support we are buying, how many new resources we are taking, what are the new servers we are buying for this. So this completely this complete cost is called the TCO. So every company wants to decrease the TCO whenever they want to start the new project. They want the lowest possible TCO to implement the project. So if you are going with the cloud computing, you are not going to buy any single server. So your TCO is going to drastically reduce, because based on your usage, you are going to use that, pay the money. So if you are buying a server which is worth 5 years of cost and you are not going to pay it, you are going to save huge millions of dollars, right? That's it. Then the pay as you go, right? Pay as you go. Suddenly you introduce a new feature in your website, and that feature is not running well, and you are going to discontinue that feature. So if you are going to discontinue that feature, if you bought 100 new servers for this feature, those 100 servers will be a waste now. But since you are in a pay as you go, right, you'll stop paying those 100 servers. Then you're going to deprecate that feature from your organization. Then you're not going to save any. You're not going to waste any money on that infrastructure. This is a pay as you go, 24/7 support. So if you buy a new server, or if you have a bunch of servers with Amazon, right, if there is any network issue, you don't need your own resources to troubleshoot it. You can have a resources with a basic knowledge, and all the advanced issues on the network, right, Amazon will be taking care, because Amazon is providing you that service. So Amazon is contractually obligated for you to provide 24/7 support, so that all the servers are 100% accessible to you. So you don't need SMEs for each thing, right? If you want to hire an SME, he's going to charge you lakhs of rupees. So you don't need SME for each and every task. Okay. Then the device and location independent. Okay. So Amazon, right? So previously, if you have a global application, your website is 24/7 up and running, and your application is running in all the 5 continents. So if you have a data center only in the American region, right? If a person from China or Asia, right, he's trying to access your website, it will be slower for him. So what you can do, if you're in Amazon cloud, right, what you can do, you can deploy it in Amazon China, Amazon India, and Amazon US. So your application will be fastly available for all the customers in all the continents, right? You can also deploy it in Europe, or else in the South America. So device and location independent. Your servers are not dependent to a region or not dependent to a network. Easy and agile development. How it is easy and agile? Because in the cloud, right, it is your cloud computing is what you say is standardized or already approved for your DevOps culture. So whenever you take a cloud, right, you can easily mold all the servers based on your DevOps culture. So it's easily understandable. So when the Amazon is created this, right, it can be easily added to your DevOps culture. So it's very easy. Utility based. Utility based is, again, right, you pay as you go everything, and whatever resources you want, you are going to pay that. Highly automated. So Amazon or Microsoft, right, will give you enough resources so that you can manage the servers in a highly automated fashion. So there will be some specific type of scripts. Amazon, what do you say? There is a tool called Amazon AWS CLI. This is a runtime tool through which you can start a server or stop a server, or you can create a server. To create a server, if you want 10 Linux servers to be created, right? If you run a single command, that is possible. You can create it. Creation, building, destruction, everything is highly automated. Okay. Then frees up internal resources. So frees up internal resources, nothing but suppose you have a testing environment. So you are utilizing very costly servers for testing environment. What you can do? You can shift your testing to Amazon cloud servers, and you can use your high cost servers for production resources itself. So it frees up internal resources. So you have your own data center, but you have started recently using Amazon AWS. So what you can do is all the low tasks or non-priority tasks, right? The testing environments or non-production environments can be moved to AWS, and all your physical servers and all your costly infrastructure can be used to utilize for better resource utilization. Okay, all these are the benefits which are easily available for every organization today, and every organization is rapidly utilizing this opportunity. So we'll see what are the service models now. Okay, so we'll see what is a cloud service. Uh, and someone will tell, right, okay, we'll take a cloud service or something, right? This, what is this name and what does it signify? We'll see. A cloud service is nothing but it is an IT resource that is made remotely accessible via cloud. That's all, right? If I have a service from my data center or from a organization, it will tell that is suppose that is a Flipkart service, because Flipkart is hosting that service from their own website. The same way, cloud service is nothing but it's any type of IT resource that is remotely accessible via cloud. Okay, so I have a company and I am taking AWS. So my service is a cloud service because I don't have my own data center or anything. So my service is a cloud service because it's being hosted remotely by a cloud provider. Okay, so whenever you go with other IT fields, right, that fall under service technology. So other IT fields are nothing but if you go to the bank also provides you service, right? So any type of what do you say, any type of service, right? Whenever you, not only IT but any other things, right? Its service is nothing but in a contextually you are receiving a support. So if you receive support from my end, it's a direct support. If you are receiving from a proxy or someone, that you call a remote or nothing but a cloud service. Okay, so a cloud service can exist as a, so what a cloud service, right? We know what is cloud service, a service which is remotely provided from a cloud provider. So that service can be in a different ways. How can that be service? So a service can be, what do you say, exist as a simple website. I told you Gmail is a cloud service. Okay, then you can also get a what do you say, platform as a service. Platform as a service is nothing but you can use that platform to create your own applications. So suppose you don't want a direct application, but you want an environment so that you can use that environment to build a application. So you let me tell you, Adobe, right? Adobe has a huge platform and service solutions. So prior to this, right, people used to buy Adobe Photoshop from internet, and it used to cost around $3,000 or $4,000. But today, Adobe, right, they'll provide the solution as a platform and service. So you are going to use their platform, then you are going to create some content. That is called a platform. So you are taking a platform. Suppose you are a graphic designer, you'll use Amazon platform to create your own what do you say, your own products. In the Gmail, you can't create any other product, right? You should only you're only using that service. You can only send a mail, receive a mail. You can't create a new email service, right? But in a platform, what is a platform is nothing but they'll provide you enough resources which are already pre-configured. Using that, you can use those resources and create your own content. That can be a graphic content, or that can be a coding, everything. Microsoft, right? If you go to Microsoft, Microsoft will provide you Visual Studio Online. So Visual Studio Online is nothing but they'll provide you all the tools through which you can build a code, test that code, and deploy that code. So that is a platform. And there is also a third one called a pure resource. So you don't want a email service or any application service. You don't want a platform. You just want a bare bone network services. Means you want to customize your number of servers, you want to customize your RAM, everything. So that is called another service. So we'll see each and every one. So the first one is infrastructure as service. The infrastructure as service is the latest type of service which is recently available in the market. So when you tell, right, I want to go with the public cloud, right? All the public clouds are based on the infrastructure as service. So infrastructure as service is nothing but you are providing a virtual server to the user. Okay, the bare bone server. So I go to the Amazon, I tell Amazon I need a server which is 4 GB RAM and quad core processor, and I need a network, and I need an IP address for that. That is called the bare bone services. You're not taking any platform, or you're not taking any software as a service. You're taking infrastructure as a service. Infrastructure is nothing but all the components which are already existing in your data center. It's a server, it's a hardware, it's a virtual IPs. IPs are nothing but IP address, because if you are creating a website, right, it needs the public IP. So you need to buy a IP address. you need to buy a load balancer, because effective you need to have your all the requests to be load balanced. Then you take a load balancer. This is a network device. Then you need a router. Then you need a switch, because you need to have your own network, right, within Amazon. These are all the services, right? You are going to ask each of these individual resource to Amazon. It's up to you. You will get your IT architect and you'll tell him that let's start architecting our project based on these resources. If you want to increase resources, it's just a single click. If you click another thing, then it's going to increase your servers from 20 to 40, and it's going to add new load balancers, new switches. It's up to you. So this is called infrastructure service. This is the most famous, and this is rapidly being utilized by all the organizations, because most of the time organizations don't want to use a software or a platform or service, right? Everyone wants to have their own solutions. So they just want a infrastructure. This is called an infrastructure service. So this is a, if you go to the Amazon or AWS or Microsoft Azure, right? They are, they are providing you this service. Guys, you have any doubt in this? Fine, guys. What is infrastructure as a service? So they are providing you hardware as a service. The cloud consumer is nothing but it's ourselves, it's the organizations or you and me. The cloud provider is nothing but the person who is providing the cloud as a service. He's a provider. This can be Amazon, IBM or Oracle. Okay. I feel everyone is fine. Let me move to the next slide. The next slide is the platform as service. Okay. So what is a platform? Okay, here, right, I don't want myself to manage my network resources or hardware, everything. I ask them that I need a database as a service. So platform is nothing but he will be installing the application. He'll be managing the resources also. He'll not be managing the application. He'll only be managing the platform. So platform is nothing but okay, suppose I want to create a web application. So if you want to create any Flipkart.com or suppose Amazon.com, right? What are the resources you need, or what is the platform you need? You need a web server, you need an application server, and you need a database, right? These three are the basic things, and you get your developers and start coding it, right? Okay. So platform as a service is nothing but this is one step above your infrastructure. So you don't want to get your infrastructure everything. I'm going to Amazon and I'm going to ask Amazon, I'm going to need a 1 TB of a database. So you'll tell I need a database with the size of 100 GB, and you need to tell that it should be very fast, it should be accessible very fast. Then what Amazon will do? Amazon will take number of servers and it will install Oracle database on it, and it will expose that database details to you. So you're not going to maintain that Oracle database, patching everything, or you're not going to patch that operating system. So you're relieving that services from you. So your resources, right, they don't need to care about what is happening on the operating system level. Amazon will take care of the hardware. Prior to this, we were concerned only from the software level. We were installing the Oracle software by ourselves, right? And we are writing the code ourselves. Here, we'll be writing the code ourselves. Maintaining the software and maintaining the hardware is now the Amazon's work. So Amazon will take care of the the OS kernel updates or OS patching, and also the Oracle service also. If Amazon wants to upgrade the Oracle, right, Amazon will make sure that it is okay. So this is not an Amazon cloud class. This is a DevOps class. This is only on the clouds computing concepts. I think someone has asked me a question. I've just replied to that. Okay, let me come back to the session. So what happens? So you're not going to install Oracle database. What you tell Amazon is, okay, I need to save my customer data, I need around 200 GB of an Oracle database instance. So, and it's up to Amazon to put how much RAM on it, how much hardware, how many softwares, what is the network resources, everything. Amazon will just expose that database as a service to us. That is called a platform. Then I'll ask Amazon, I need Tomcat. Then can you create servers? Then you'll directly take your ER and you're going to deploy that. You're not going to install Tomcat or not going to manage the Tomcat server. That is called a platform as a service. They'll provide you as a platform, and this readily available platform can be utilized by the organizations. Use it, because if it is a startup, right, the startup will not have enough money to what do you say, buy hardware resources or manage network things, because if there is a startup, right, they want with less number of resources, they want to start their company. So if they take a platform, right, it will be easy. They can just take developers and they can ask Amazon to create a database server, provide their credentials. They'll give the username, password, and the JDBC connection URL. They can directly use it in their code. So this is called a platform as service. Okay, guys, you have any doubt in this platform as service? No doubts? You understood what is a platform? Okay,
I
okay.
have one question, Gautam. Like, do we need to take again infrastructure for this? No need for that, right?
You don't need to take infrastructure. You'll only tell, I need a Oracle database which is highly available with 100 GB of space or 200 GB of space. It's up to Amazon to decide how many servers, how much RAM to give, how to install that software, everything. I'm not going to care anything. I'm only getting a database with 200 GB and I'm going to utilize that in my application. In my Java code, I'll put it. Then my what do you say, the transactions or user information will start storing in there. If I feel that 200 GB is completed, I'll tell, can you please increase it with 100 GB? Amazon will increase it. That's all.
Okay.
So it's very easy, right, for the startups or for any organization, right? They no need to have concern or headache about server crashing or application slowness. Amazon will make sure that that database is 99.99% available, because it's a contract. Amazon will tell you. Otherwise, you can ask Amazon to pay fine, or you can tell, okay, you have not provided service, I'm not going to pay money. Though you'll use it for 95% of the time, if he's not able to give you 5%, right? They'll have some fine structure, because the same way, if you have taken a project from Bank of America, if Infosys takes, right, Infosys also has SLA, they'll commit for 99.5 or 99.9. If they are not adhering to the SLA, right, they are going to get fined. The same way, Amazon is also responsible for that fine. So we are going to see the third type of service model. The third type is a software as service. So software as service, it's the oldest type of cloud computing service, right? This started in 1990s. So if you take Gmail, whatever the service today, if you take Google Drive, everything is service, right? I'm not installing server software. I'm not installing the platform. I'm just using the application. That's all. I'm going to log into gmail.com. I'll use Gmail. That's all. I don't have any customization here. I can't write a code. I can't manage the service. I'm not even managing the application also. What is this? So you're not maintaining any layer of the software development lifecycle. You are coming as an outside person. You just use that and you leave it. If you take a SAP Cloud, right, that is the same thing. You just go there, you utilize that service, you come back. This is called a software service. Okay. Typically we'll be what do you say, encountering software service in our daily lives, not the platform or infrastructure. We'll only see that in the organization, but software service everyone will be seeing in a different ways. Okay, guys, you are fine with the service models, right? These are the three service models you have. Let me move to the another thing. So here, right, I am trying to explain you in a good representation. Okay, so just see this. So if you see this blue color, right, this signifies that you are managing this. The green color is vendor managing or the cloud vendor manages. Okay, if you are having your on-premises or your own data center for your organization, right, you need to manage each and every resource. You need to manage your networking, your storage, your servers, your virtualization, your operating system, your middleware, your runtime, your data and application. Each and every component should be maintained by your own persons, right? You understood, right? So in your on-premises, everything should be managed by your own teams. So when I move to the cloud solution, right? So if I move to the infrastructure as service, I'm not going to care about the network. I'm not going to care about the storage. I'm not going to care about the servers or virtualization. I only start caring about the operating system, right? So if you take infrastructure as service, right, you take 20 servers, right? If there is any network connectivity, that is not your issue. You tell Amazon that, okay, my servers are not talking to each other. Can you see it? Because Amazon has provided as a server only. It didn't provide a network access to it, because Amazon will take the backend work of virtualization, the servers, storage, and networks. Because so Amazon will create a huge pool of what is storage, and from that pool it will tell, okay, for your one server, you asked 100 GB, I'm going to give you 100 GB. If that 100 GB is not accessible, that it's not your work. Amazon is going to resolve that issue of that storage issue. Okay, so these 4 parts will not be taken care of you. So infrastructure service, this will relieve you these 4 services. So if you take a platform, what are the services it's going to relieve? Apart from this, you're not going to manage your operating system, you're not going to manage your middleware, you're not going to manage your runtime. So we'll see the example. So when I ask the Oracle database service, right, I don't care Amazon is installing on Microsoft server or Linux or Ubuntu or RHL. I don't care on whatever operating system is installing. Okay, and I don't care what type of service is also is providing. Okay, whether he'll install full version of that, whether he'll install Oracle, whether he's going to install in a cluster, that middleware I'm not going to care. And also I'm not going to care how that Oracle is being patched, because I don't want to take the issues of patching, downtime, everything. That runtime is also maintained by the Amazon. So these 3 also will be taken off from your table. If you take software service, everything will not be, nothing will be managed by you. You don't manage the runtime, or you don't manage the data, you don't even manage the application. In your Gmail, right, your who is responsible for your Gmail data? Google, right? You don't have, you're not managing your data, or you're not owner of your data. You told that though it is my data, Google also has enough permission to save the data and see the data, right? If you read the terms and conditions, this will be there. So you're not even managing your data and not even managing your application. So based on your requirement, right, organization can go with any of this service. So if you need a new type of a service where you don't have that team resources, right, you can go with the platform service. Then you no need to hire that expert. If you are going with a new service, some new type of technology, and you don't have resources for the technology, you only have a resources who has basic knowledge, then you can go with a platform as service. Then you can only start creating the instances, or start creating the resources of that software. If you have enough resources, if you have enough SMEs, then you can go with the infrastructure service. Then you can ask that person to configure the operating system, install that software, and maintain that runtime. Okay, and if you don't want anything, you can go with on-premises, where each and every aspect is customizable as per you. Guys, any doubt in the service models? These are the same 3 service models, but I have shown you in a different graphical format. Any doubts, guys? No? Okay, let me move to the next slide.
Gautam, is Vishwar.
Yes? Yes, Ishwar?
Initially, if we prefer infrastructure, can we switch to some platform and platform to software? Can we
Yeah,
switch
you
like
can
this?
switch. Yeah, so you have an existing database, and it has become a very big headache or bottleneck for you. What you do, you take a new platform as service, you migrate your data within half day, because Amazon or these cloud providers, right, they have very good migration tools, because they want so many people to leave their own data centers and move to the cloud, right? So they have created a huge number of migration tools. So you can use a migration tool of those cloud provider, and you can migrate your data there, and you can start using the service, and you can destroy this infrastructure service resources. It will be only a couple of days for you to do a migration. Or if you want to do the return migration platform to your right, then you can install all the databases, then you can install database in multiple servers, then you can create a load balancer, all these things. You can create a Oracle database highly available, then you can start loading the data. It's up to you. But there will not be, it will not be a huge task. It will only be a mere number of days to switch from a type of service to another service.
Oh, okay.
Okay. Yeah. So we have seen what were the service models, right? So how they ensure that data is safe? Okay, yeah. So how they ensure data is safe? Let me tell you guys. So logging into Amazon or any Microsoft Azure, right? It's highly secure, and they have all the LDAP capabilities. Whatever you have currently using in your organization, right? Those capabilities can be added to your Amazon servers. So if you have a traditional LDAP service and you are using that LDAP service in your organization, you can directly integrate that to your Amazon services. And let me tell you an example, guys. So if you take Microsoft, right? Microsoft is investing 7,000 crores or $1 billion yearly on security. And these persons, right, these are the highly compliant services. So compliant is nothing but the way you have ISO rating, right? The same way every cloud service or every server, right, it will have a rating. So that rating will be provided by the rating services. So the cloud computing cloud providers, right, they have the highest rating of any other providers, because if you take a bank, right, the bank has highest standards of security, right? So you'll have higher than those standards, because they'll be investing huge amount of money in the security and safeguarding the resources. So suppose let me take an example of a Wells Fargo. So I know the Wells Fargo budget. Wells Fargo's IT budget is $1 billion. So with that $1 billion, they need to manage 7 or 6 data centers, everything, all those things. But when you go to a cloud provider, right, they know that if there is a small issue, they are going to lose huge number of resources. So they have invested huge amount of money in the security, and they have become the highest standard or highest compliant network providers or service providers in the market. So we can easily guarantee that there will be more secure than your own data centers currently. Your data centers will have thousands of vulnerabilities, but those services, right, they will not even have a single vulnerability. Any vulnerability, they are going to fix it as soon as possible. Okay. Is it fine now, Shaji? Okay, yeah. So always, right?
In software as a service, like what is the restriction? Is it like we can use only the application they have, or we can
Yes,
move
so you
our
have a
applications?
software service, right? What you can do, so they will provide you a authenticator service. So suppose you know what is what is Active Directory, right? You know Active Directory, everyone will have Active Directory in their environment, and they'll use Active Directory to log in, right? What you can do is you can use the same Active Directory configuration and configure that to that SaaS solution. So anyone with your exact credentials of your organization only can only to log in that. It's not like, okay, I'll use my Gmail and I'll create a Gmail and I'll log in. No, you can integrate your existing Active Directory or Oracle IAM to that SaaS based login. Then only your organization people are going to use it. So yes, they will provide you enough integration to your existing security solution so that you can implement the same solutions there. If you want two-factor, yes, you can enable two-factor also, which is already in your solution, in your deployment. You can use it. It's not like, okay, they'll ask you to create a Amazon or at gmail.com. No, they are going to allow you to integrate their Oracle IAM or Oracle Identity Manager or what do you say, CA Site Manager, whatever it is, whatever your existing security solution is there, you can integrate there. Okay.
So it's like we are referring Active Directory as an application.
As a security solution, Active Directory is not an application. Active Directory is a LDAP
No.
provider, right? Yeah.
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 My
You're
question is like, my
yes.
question actually is like, in the software as a service, applications which we are taking from them is like the application provided by Amazon, or we can move our applications there so that they will
No.
maintain
It's
everything.
their application. No, that will become platform. Software it's their own.
Yeah, right. Yeah, then
Yeah.
it's clear.
Okay. Okay. Let me move to the next slide. So what we have seen is these were the service models. So how are you going to deploy that service? That service will become the deployment model. So you have a SaaS solution. How are you going to deploy that SaaS solution? That model is based on that model, right? That will get a unique name in a cloud computing deployment structure, right? So we'll see what are the 4 types of deployment models. So the 4 types of deployment models which are available, right, are the first one is the public cloud, then the private cloud, then the hybrid cloud, then the community cloud. Let's see each and every one. Okay. So the first thing is the public cloud. Public cloud is nothing but the cloud which is accessible to the public. So it is a type of cloud hosting in which the cloud services are delivered over a network which is open for public usage. This model is a true representation of cloud hosting. So why it is true representation? In this service, right, the provider renders you the services and infrastructure to various clients, not only a single client. So the customers do not have any distinguishability or control over the location of the infrastructure. Okay. And from the technical viewpoint, what you can tell is there will not be any difference between public and private cloud except the level of security offered. Okay. So the public cloud is nothing but this is the most open type of cloud solution you can get. So when you go to the Amazon AWS, right, that is a public cloud. What is a public cloud? So in that public cloud, right, suppose your Flipkart, see, Flipkart is completely on cloud. And what do you say, Snapdeal is on cloud. Whatever the Indian startups today, right, they're all on cloud. So if they are all, and most of them are with Amazon, so most of them will be sharing the same data center, which is in Mumbai location or Chennai location. There are 2 data centers for Amazon. So you'll not have your own data center. You sometimes, right, some people will think, okay, I don't need that much own my own security or own restrictions. I'm fine and I can go and reside in public cloud. So public cloud is a cloud solution where it's open to the public. So multiple clients or multiple organizations will be using the same type of resources which are from a single location. Okay, this is called a public cloud. So what is a private cloud? Private cloud is nothing but this is also a type of public cloud, but this is restricted to a specific number of type of organizations. So Amazon, right, in the US, right, Amazon has a cloud which is for a Department of Defense. So it's called DoD. So there is a cloud. Amazon has created a data center, and it is called a Amazon cloud, Amazon DoD cloud. So in this DoD cloud, right, all the American defense organizations, right, like the Navy or everything, right, if they have their own applications, they can deploy those applications there. This is called a private cloud. Private cloud is nothing but it's only private to particular set of people. So it is intended for a single tenant. So if you sell it, this is called a community cloud. Sorry guys, not a private. Community cloud is nothing but this cloud is still a public cloud, but this cloud will be restricted to particular types of groups or organizations. So this is called a, there are 2 types of Amazon like this. One is called a government cloud. One is called a Department of Defense cloud. Government cloud is nothing but all the public utilities. Suppose you'll have your GHMC or your or else your electricity department or your interboard, right? These are all public utilities, right? These can have a own data. So because still this is a secure data, so that time it will go to the government cloud. So if there are some military people, right, they'll create a DoD cloud. So these are called a community clouds, where it will still be accessible to the public, but that public will be a restricted set of organization or resources. Okay, this is called a community cloud. The private cloud is nothing but this cloud is only intended for a single user. So all your current your own data centers, right, they're all called public private cloud. Okay, you have your own data center, right? The data center will be a public private one, right? That is called a private cloud. So where a cloud, all the cloud solution or all the data center will be only provided to a single person, that is called a private cloud. Okay, and the next thing is called a hybrid cloud. Hybrid cloud is nothing but it is a combination of a public cloud and a private cloud. So suppose let me tell you an example of a hybrid cloud. So suppose I have a bank called SBI, State Bank of India, right? So the most important data of the State Bank is the customer data, which is residing in their databases. They can use whatever database they want, but sometimes they'll think the most important or heart of the SBI is their data. So they'll think, okay, I will not use the Amazon, I'll use the Amazon or Microsoft services only for my web servers and app servers, and I'm going to use my database as in my own private cloud. So what it will do? The first when the request is hit by the user, it will directly come to the Amazon. Then the request will go from the three-tier architecture, right? The web server, app server, and the database. So it will come to the web server layer. Then it will go to the app server layer. When there is a request for the data of the resource, right? Then that request will come from the private cloud to the public cloud to the SBI's own data center. It will be encrypted. It will be on SSL connection. Then it will retrieve the data and it will send the data back to the private cloud, and that data will be given to the user. This is called a hybrid cloud. So sometimes, right, people are not yet 100% believing in the cloud solution. They'll think, okay, my most important data and services I'll use from my own data center, and some other resources which I feel are not that most important, they'll be putting in the public private cloud. This public cloud. This is a combination of public and private cloud is a hybrid cloud. Guys, you understood what is hybrid cloud? Guys, you understood?
Can you explain the example again?
Okay, yeah, okay. Let me take an example. So there is a bank, and that bank, right? The most important data of any bank is their customer data or else the account data. Everyone should not know that this much money is in this person's account. This person has this loan. No one should know. That is the most private data of an individual person. So, and this bank, right? They want to expand. They want to start using this cloud because they thought, okay, buying new servers is becoming costly, and they want to go with the cloud solution. Guys, there is some disturbance. Can you see whether everyone is muted? Can you see everyone is muted because we have a disturbance? Okay, let me. See. Okay, yeah, I think everyone's mute. So this organization, right? They want to go to the cloud, but they are not having 100% confidence on the cloud. They don't still believe the cloud, and they have some doubts on the cloud. Some people will have doubts that, okay, if I put my data in Amazon, what if Amazon will open my database and see? Because Amazon is hosting your data, so Amazon will also have access, right? Though Amazon will tell you it will never touch your databases, but still some organizations will have doubt that, okay, what if Amazon will open my data? My data is very important, my customer data. So what you do is you use a hybrid solution for your application. So your application has your web server, which will take the request from the user. Then you will have an app server like a WebLogic or WebSphere, where it will understand the request and it will send that then that understood request, right? Based on the user request, right? It will go to the database and fetch the data, right? So this is your 3-tier architecture. This is the standard architecture where any person is going to deploy any application. This is standard. So what you do is your web server layer and your application server layer will be in your public cloud with the Amazon. Your database layer will be in your own data center, which is your private cloud. So what happens is when the request comes from the user, the request goes to the web server layer, then it goes to the app server, where these both components are in the Amazon. When the request comes, right, okay, when you tell check my balance, right, what happens? The request come to the request goes to the web server layer, then the app server layer, then the app server, it will understand that, then it will create a query on the database, select suppose called Ravi from his savings account with a number. This query will be run on the database. Then the database will give that information. So the database, right, this database will not be in the cloud. It will be in your own data center or in your private cloud. So this is called a public and private cloud. So some of the operations of your request will be done in your public cloud, and some of the other operations, right, will be done in your private cloud. The combination of private and public is called a hybrid cloud. So many organizations, right, suppose, let me take another example. Suppose there is a hospital called Apollo Hospitals, right? So if I know what defects are with other person, I can misuse the data, right? Suppose if I know that some person is having a BP or some person is having heart attack, then I can take an advantage and I can do something so that I can harm the people. So what is it? Health data is more important than banking data, guys, because health data is the most important data. So in these scenarios, right, what they do, they save that patient's health information in their own data center, and they'll use the web layer in the public cloud. So when there is any request for that information, right, when the user logs in and they want to see those data, they send that request to their own cloud and they fetch the data, and that communication will be SSL. It will be 2048 bit or whatever encryption you want. Then that will be a secure connection. You guys got it? Now what is a hybrid? Okay.
Gautam,
Think
like
everyone.
thing, like it's about the same organization having their data or something like that, right? Or is it like
Yes.
Amazon also going to
No,
provide
no, same
private
organization,
cloud?
same organization. Amazon will always give public cloud or a community cloud. They'll not give private cloud. Private cloud means they'll not create a, see, building a data center will always require a minimum of $500 million, which is equal to 3,000 crores, because you need to have a huge land, you need to install thousands of servers, network connectivity, routers. So Amazon is not going, but if you commit Amazon that, okay, I need this many 10,000s of servers and this one, then Amazon will start building you a private cloud. Okay.
Okay, okay, yeah,
Yeah,
got it.
based on the requirement. Yeah, but most of the time people will not, right? At the most, I have seen organization will use 20,000 servers. So whenever you create a data center, right, you'll have easily scope of creating 50,000 servers. So not even single person can match that requirement. So it will become a community cloud itself or a public cloud. Private cloud will never become. We don't know in the future if Amazon will create one data center only for Flipkart. We don't know. Yeah, but that is a possibility still. But till now there is no requirement for these public providers.
Thank you.
Okay. Yeah, that's it, guys. So tomorrow we'll see what is the basics of AWS, and we'll also set up our lab session tomorrow. How are we going to set up our lab? Everything we'll be discussing tomorrow. Okay. So I'll give an introduction in the AWS, and we'll have our all the labs in the AWS, guys. So I'll tell you how to create your own account, how to do this, so that you can create your account in the Amazon, which is freely available for the first 1 year. So tomorrow we'll see how we are going to use the lab session. Okay. How are we going to set up our lab? What is the Amazon? So all our all our lab sessions, right, will be shown in the Amazon servers. But it's up to you. See, Amazon means nothing but I'm creating a new server in Amazon. If you want to practice in your local server, that is fine. But using Amazon, it's easier because whenever you install a Linux operating system, fresh install, right, it will take 2 hours for you, and you need to have a huge computing resource in your laptop. You need to have at least 8 GB of RAM. If people have that, it is fine. But still, you'll have a lot of resources. If you install a RHL server, RHL, what do you say, software by yourself, right, you'll face many issues. So that's why I'm going with the Amazon Cloud. It's easy for you. You can practice wherever you want. If you want to practice it in your organization, sometimes if the Amazon is approved, you can still go there. So tomorrow we'll see what is AWS, and we'll create a AWS account tomorrow, and we'll see how to create a new server and how to destroy server. Okay, so that this will become our base of lab. So from the day after, yeah. Yes.
Gautam, this is Anil joined. I'm sorry, like I just joined late.
Okay.
Can you just let me know what is the agenda of this course, like what you will be covering as part of DevOps?
Okay. So you, sorry, what's your name?
My name is Anil. I've just joined 10-15 minutes back.
Okay, Anil, can you just ping me your email so we'll have a discussion? So I think the session has completed. So yeah, you give me your email. So guys who have newly joined the first session, just ping me their IDs. I'll talk to you. Okay.
Okay, and
so all other people. Yes.
What can be the prerequisite for this course?
Prerequisites are nothing but you need to have a normal networking. You need to know what is a Linux server. You need to know basic Linux command like CD, LS, all those things, and you need to have a basic understanding of what is a web server, what is HTTP request, all these things. Okay.
Will you cover this automation tools in this DevOps?
Yes. So you gave me email ID, right? So we'll start covering it. All the team, all the persons who are already completed. So the today's session is completed, guys. Whoever want to leave the session, they are fine to leave the session. I'll talk to these guys who are joined today. Okay. Have a good day, guys. Okay.
Thank
Yes.
you.
Yeah. Yeah. Thank you. Rajshekar. Okay. Yeah. Thanks, Ajay. So let me see the chat window. Thank you, Satish. So anyone else has a doubts? Means on regarding the course. I think all the persons of the regular course has disconnected, so I can give you some what is a clarification. So you wanted to know what are the things which will be covered, right? I think it was a Raja who was asking like what are the DevOps automation tools which will be covered, right? Who is it? Someone has asked me a question. Who is this?
This is Raja.
Yes,
Just
yes, Raj.
thing that
Yeah.
yeah, to whom I have to contact the related details and all. It's Vybhava Technologies.
I didn't get you.
Means field structure and all.
Yes.
To whom we have.
Yeah. You drop your email. We'll contact you. Okay.
Okay.
Okay. You can just give me your email ID. You can drop your email ID, then we'll contact you. Okay.
Yeah, I got already.
Okay. Yeah, yeah. We'll just contact you back after the session. Okay.
Okay. Okay.
Yeah.
Okay.
Yeah. Anyone still, they can drop me the mail. I'm going to contact you back.
So Gautam, you can also take down my mail ID. I've pinged in the chat.
Sure.
It's epikumardb@gmail.com. So
Yeah, I'll
actually,
just take it.
I'm from an admin background. So I'm
Yes.
actually an Oracle DBA, Oracle Apps, Hadoop, and Fusion middleware.
Okay.
So how this course would be an added advantage to me, and what are the tools that you're going to cover as part of this course? I'm keen interested in those areas
Yes.
actually.
Yes. So as part of this, right, we'll be covering each and every aspect of DevOps automation. So DevOps is nothing but there are 5 automation stages. So we'll cover the Jenkins, Chef, Puppet, uh, Vagrant, Docker, the basics of AWS,
Mhm.
Nagios, and JIT. These are all the tools in the various phases through which you can completely automate your existing environment. So if you have a Fusion middleware, if you want to automate it, yes, you can do automate everything. Whatever IT organization needs, right? These are all the tools through which you can automate your uh, software development lifecycle. Okay, so because when you
Yes.
tell, I'll tell you an example. If you still database, right, people will not have much administration on the database. Once you set up an database, right, people will not have much administration, right? But still, there are more other moving parts in your organization where they need frequent service, right? So those services will be usually impacted, or huge resources will be wasted. If you have an operating system patching, right, it's a huge resource. If you want to install a new package, right, it's a huge resource waste. So we'll make sure that all the tasks in your environment are what you say easily coverable, and they're all automated. So the testing will be automated, the build will be automated, all these things will be automated, and the new server creation will be automated, all these things. Okay.
Okay, so for this automation tools, the Chef Puppet and the Jenkins, whatever you said. So for
Yes.
these tools, do we require any programming knowledge on that, or what kind of a
No,
knowledge we require?
you don't require much programming knowledge. You only need to understand the requirement, and you'll have a specific documentation. So I'll tell you, if you as a you need to be an IT person. That's why you don't need any background on programming, because the writing programming is very easy for the, Puppet and Chef. They are very easy. So if you know at least 10% or 5% of a programming knowledge, that is more than enough. So
Mm,
yes,
okay.
because when you write this code, right, you'll not be writing hundreds of lines. You're not a real-time developer. You're only writing a specific task of code. And so I'll tell you an example when you write a Puppet. So if you want to install Postgres database, right, what you'll do, you'll take a installation, everything, right? But installation of Postgres database, or anything, right, on a open source database, right, using Chef is only 3 lines. You tell package, Postgres SQL, action, install, done. That's all. Those 3 lines are enough. So you think that, okay, I'm installing so many things. What is it? When you come in the terms of these languages, right? These languages are very easy. I just gave an example. If you are installing a software, that is only 3 lines of code with the 6 sentences. That's all. You'll tell package, Postgres, action, install, end. That's all. That is the 3 lines of code which you need to write in a Chef or Puppet. So the learning curve is very easy for this programming, because you'll be writing in Ruby language, and the Ruby language will not be utilized at all. You'll only use a one kind of a Ruby language in the for loop. Other than that, you're not going to utilize any programming structure, programming knowledge, or any other component of this. Okay.
Okay. Okay, Gautam.
Yeah.
Thank you.
Yeah. Guys, you have any
So
other
I
doubts?
guess like you would be posting the agenda and the modules that you're going to cover in this course,
Yes.
isn't
Yes.
it?
In
I've just
detail.
checked my
Yes.
mail ID.
Yes. 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 I'll cover
Okay.
in detail. I'll send you detailed
Okay.
information. Okay. Yeah.
Thank you,
Thank you.
Gautam.
Yeah. Guys, any others has doubts? Everyone is fine.
Yeah, we are good with.
Okay. Yeah. Then yeah, we can end the session. Yeah. Thanks, Satish. Thanks, Satish, for hosting session. I think we can drop this call. Thank you, Satish.
Thank you, Gautam. Have a nice day.
Yeah, bye.